VBA users, people who don't know what VBA are, and people who know that Google Sheets has JavaScript. So today we are looking at this Google Sheets chemistry calculator thingy-majig. There isn't really a title for it. It doesn't matter that we don't have a title for it, because it does something actually useful. And you might just be thinking, this is just a wall of falses and A's and whatever this is. And you would be absolutely right. So the question is, what does this Google Sheets actually do? Well, I can answer that very simply by putting in here a random compound, say vanadium 4 carbonate. And as you can see, it fills out all of this, and once it finishes loading, we get VCO32, which is the formula for vanadium carbonate. It is, of course, a base because all carbonates are bases. Of course, it is insoluble because most carbonates are insoluble. It is not a salt because it's a base. And then output preparation reaction, well, we don't have an salt preparation method, so there isn't anything to do here. Then we have the output reaction. Now this actually involves the second sheet, which I'm about to show you. So this is the second sheet, and you might be thinking it is exactly the same thing, but you would be wrong, because it doesn't have the output reaction bit here, because it is the second sheet that doesn't have a proper name, because I just cloned them, because they're exactly the same. Anyway, so here we can put in another random compound, say iron 3 nitrate and FeNO3 is of course the correct formula for iron 3 nitrate. It is a salt because it is a nitrate. It is soluble because all nitrates are soluble, and so you would use the insoluble base method of preparation, which would be iron 3 carbonate plus nitric acid. And then this is just a weird thing, it doesn't matter, it's for a future project. And to the magical land of the original sheet that has no copy in front of it. And as you can see, this is where this final bit comes in. As you may remember, we did vanadium carbonate, which is this right here, and iron nitrate. So now it reacts them together, and so if we extend this, you see it is vanadium carbonate plus iron nitrate goes to vanadium nitrate plus iron carbonate. And these are of course all the correct formulas. And over here we have the word equation, which is vanadium 4 carbonate plus iron 3 nitrate plus vanadium 4 nitrate goes at plus iron 3 carbonate. And let's just extend that, because that would go on mildly infuriating. And so the way that it does this is over here, as you can see, we have vanadium nitrate, because that is concatenating this and this, which produces vanadium nitrate, which is, of course, it knows that that is what would happen if you swapped around iron and vanadium. And as you can see, this does the same thing, just the other way around. You get iron 3 carbonate. So it works out everything about these, so you can go to these to see the solubilities and preparation methods of all of these. This one is iron 3 carbonate, which is insoluble, and so you would use the precipitation method, which is iron nitrate plus sodium carbonate. That's a fairly easy one to produce because you just use nitrates and sodiums. And this, of course, is the irrelevant bit that we don't need to worry about. At work, we're going to be looking at this first sheet because all of the others contain everything in here, just a little bit less. So then obviously it starts with this VLOOKUP. Now essentially, if you wonder what this is looking at for, you can see right here key, and I'm sure you can guess what that is. Over here we have the periodic table in symbols. We have whether it's a metal or a non-metal. We have valencies, 10 means variable. And this is going to get changed later on because things like nitrogen technically have a variable valency, but we're not going to worry about that for now. Then here we've got all the names, and as you can probably tell from here, we don't have astatine, francium, or everything after uranium. And do you want to know why that is? It's because you can't get the formulas with any of them, because there aren't known valencies for them. Anywho, down here we have what is essentially a reactivity order, and also down here, because trying to get them to coexist with each other caused a few glitches. And down here we've got lowest common multiples for all of these numbers 1 to 8, because that's what's going to be used when I finally add skeuometry to this. So then it needlessly re-expands this back out, because yes, I know this is not in the most ideal form it could be in, but my Google Sheets was not running VLOOKUP as originally expected, so a lot of these VLOOKUPs weren't working, which is why it's here, but not here. So essentially what this does is it detects whether this is the element corresponding to the box, and this of course has matches to the periodic table twice over, one for each of the elements. And so then that gets the element, and then we go through a bunch of decoding until eventually we get to this monstrosity. But before we get there, we have this right here. Now essentially what this is it has summed this entire area, because somewhere in this area it has the valencies. Wow, isn't it magical? And so then, as you can see, it sums all of it up, and then we end up with our valency of our first element here, second here, and first here again, because that just meant that I could just clone these two commands. And essentially what this command here does is, and I could also clone these ones, essentially what this is it looks, if this is 10, then that of course means that there's a varied valency, so it's got to look right here where it's split off the Roman numerals. Checks, is it I? If it is, then it's 1. If is it II, then it's 2. If it's III, then it's 3. If it's IV, then it's 4. If it's V, then it's 5. If it's VI, then it's 6. If it's VII, then it's 7. And it's VIII, it's 8. And same there. And then this is just, you know what, I'm just going to be the same as this, because why not? Anyway, so then here, what it does is it essentially matches it down. So essentially, if they have a highest common factor, it basically divides. And because Excel doesn't have a function for highest common factor, and yes, I know, I could have used the JavaScript, but I was stupid, and I didn't. So we're stuck with this monstrosity of ands and ors and ands and ors and but anyway, it then gets them down to the amount of each element that it has to be, which then go up here, and so do the elements, or the symbols for them anyway, and that brings us back down to this monstrosity of, like, seriously, whenever anyone sees this, they just think, what the absolute hell is this? Because, I mean, like, So basically, this is what I decided to do when the VLOOKUP decided to not work at all, because ordinarily, I would have just VLOOKUP'd this entire area for any symbol, and VLOOKUP'd for a symbol in this lower region. But instead what it does is it concatenates so that it brings all of that section down to here, or this level, and then it brings all of that section down to this level, and then this is basically, it will copy this, and then this will also copy it, which is what brings it across. And the reason why it's so long is because if you're coming from here, the slope just about brings you to this corner. Now, of course, nothing can actually be there because this AI doesn't actually correspond to any elements, so it's a little bit pointless, but I mean, it works fine because we always get our 2 elements down here. Anyway, so then, this is basically corresponding to, is it a metal or is it a non-metal? And so that gets pretty complicated, and so it works out, oh yes, these are metals. There's a metal and a non-metal, and then there's actually an override for if it's carbonate, hydroxide, oxide, it outputs base, but usually with a metal non-metal compound it will output salt. Over here we have the acid override, and this is actually the bit up top that is a little bit broken because it won't return the correct acids for the reaction that produces the salt preparation. Down here is the start of the stoichiometry, and here we have the reactivity. Now you may remember over here in the key we have the reactivity of all the elements. It is of course inverse, so noble gases are 24 because they're very unreactive, and cesium, because I don't have francium, cesium, oxygen, and oxide are of course the most reactive things because oxygen reacts with basically everything. Anyway, so that then corresponds up here to this, which is producing whether or not we have the reaction. So this reaction here, essentially, this large thing is essentially, is it a precipitation reaction? Okay, this first bit, okay, that AND gate. And then here we have, oh yeah, is it neutralization, blah 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 blah. And then we have a few other things for, oh yeah, shouldn't be this and this because they don't actually react even though you might think they would. And then over here we have, oh yes, it's not going to go downward, something that is less reactive than something else can't displace it. So for example, nothing can displace cesium, okay? And nothing can displace oxygen from anything other than oxygen. So that's just clearing that up. And so those are the 2 reactions, and then these all just have the exact same processes as do these, but we're not going to look at those because they're something separate. Like, subscribe if you liked the video, and if you didn't, then I guess comment down below what you didn't like. It might be something I can change. Anyway, bye!